My name is Anand Pashupathy. I'm a vice president and general manager at Intel, and I lead the confidential computing stuff at Intel.
Wonderful. And I'm Marshall Kirkpatrick.
Nice meeting you, Marshall.
Nice meeting you as well. This is a big, exciting, dynamic space, but it's something that a lot of organizations struggle to tap into. I wonder if you could start by telling us some of your favorite stories about data and security barriers, blockers to utilization of AI that were later resolved by the implementation of confidential computing.
Sure. I think the biggest concern people have is who will get access to my data, right? And traditionally, what companies have done is lock that data down, lock it down in a way that they have access controls of who gets access to it. They have RBAC, lists on making sure only the right people get access to the data. And collaboration was extremely difficult and arduous at the end of the day. I have been in this industry long enough to know where, we had to get signed paper on either side before we could actually send information back and forth between companies. And I think confidential computing has completely upended that, right? I can actually do multi-party computing, between two companies, having full confidence that my data is not going to be shared with another company. And I can actually get better results because of that multi-party compute. And with the advent of AI sitting on top of that, I think there are so many new schemes that are coming up, like federated AI and things like that, where you don't actually have to move your data to a central location. The model comes to you. You operate it on your data, and then the model kind of traverses through its entire federation and then gets better, and then the cycle repeats again, right? None of that would have been possible without confidential computing.
What are the outcomes there? And can you give us any specific examples of positive business outcomes as a result of the successful implementation?
Sure. I just came out of my keynote at Confidential Compute Summit. And one of the examples I used there was how one of our partners, Microsoft, moved their entire credit card processing to the cloud. Now, think about this. This is a regulated industry, right? Which is, has all these policies and regulations and standards that you have to adhere to. They moved that entire system to the cloud because of confidential computing, because of the trust that they have that the underlying hardware layer, Intel SGX in this case, supports that use model and supports the protection of their data against anybody else's unauthorized access. I'll give you another example. This was another example I quoted. When you look at the European Union, they're very big on the sovereignty of their data, where they don't want data from Germany to leak somewhere else or vice versa. This was another example where at scale, we have deployed, or the German Ministry of Health has deployed a confidential computing system for delivering e-prescriptions to all of their citizens, which is, again, only possible because of confidential computing. So you can't beat these scale outcomes. And then there are several other proof of concepts that people are driving to really figure out how do they get their data unlocked from whatever silo it is sitting on out to the cloud and allow access to it in a confidential and privacy preserving manner.
It's remarkable to think about this unlocking access to European markets for international companies and access to international technology for European governments and markets. How is this being received in Europe? Can you tell us a little bit about that?
So all of these technologies are following regulations that are already in place in these countries, right? So these are designed to support GDPR or the government laws in Germany. So it's in support of that. It is being done in the country, and there is assertion being given that the data never leaves the four corners or the points of the country. So that level of assertion is what is allowing them to go deliver this e-prescription solution in Germany, for example. And I am very sure as that transformation continues in Germany and other countries in the European Union, they will start replicating this in other countries as well.
Wonderful. Will you tell us a little bit about the positive business outcomes of the multi-party compute in particular? That's such a novel feeling and exciting opportunity that's
Sure.
here.
I'll give you a very simple example to make my point. So let's say we have a bunch of hospitals who are all doing cancer research, okay? Hospital data or patient data is another regulated data that nobody wants to part with, right? So in that example, instead of the data going to a data clean room centrally where it's processed in a confidential manner, the model actually comes to you. So you get a model from a central repository, it gets federated and shipped to your data, you run the model on your data, and whatever delta prompts or delta weights that need to be adjusted get sent back in a confidential manner back to the central repo that gets this collection from all of its federation, puts it together, and does model prime, which is better than model, and then sends it back out again, right? So now I have full confidence and control over my data. It is not leaving my premises, but I'm getting the benefit of this model that is also acted upon by other people's data without that data leaving their hospital or their premises, right? Think about that. Can you think, I mean, I'm just amazed talking about it because that would not have been possible without confidential computing by any stretch of anybody's imagination.
Can you tell us a little bit about Intel's strategy around confidential computing and how it's changing now in 2024?
Yeah. I think everybody got hit by the AI bat. And, we're like, oh my gosh, there is this opportunity in front of us, right? I said it, the speaker before me said this as well. It's a force multiplier for confidential computing because what is AI acting on? It's acting on data. Your models are data, your prompts are data, your parameters are data, the results coming out is data. So it's almost like a problem statement made for confidential computing. And if you go look at documentation about the European Union AI Act or the executive order in the US, they're all talking about, protecting your data against anybody doing any attacks to the data. There should be no hallucination. Bias, I don't think will be impacted by confidential computing. But the bottom line is this is all just data. Now, if I can assert that data is being operated upon inside a confidential computing manner, inside a confidential computing enclave, there's just benefit for that. So while Intel started this journey on confidential computing with Intel SGX, it allowed you to have smaller trust boundaries, so you get finer grained control on what gets acted upon. We have introduced TDX into the market, which allows you to basically do it at a VM level. So we did application level, we did VM level. We have independent trust authority that we have delivered with Intel Tiber Trust Authority. So now you have trusted execution environment, you have an attestation engine or a service that attests that your workload ran there. That's what is available today. I can take advantage of that for confidential computing and for confidential AI, which is really at this intersection of confidential computing and AI. Moving forward, confidential AI or the ability to run really large models with large parameters is just going to increase and explode, right? This is where Intel is introducing Intel Trust Domain Connector or TDX Connect, which allows you to connect the CPU with an external accelerator. It could be a GPU, it could be something else like that. So that in combination of the CPU with the GPU, you can deliver even massive scale artificial intelligence solutions in a confidential manner. That's what is in our roadmap. That's what we are working to deliver. And we are rallying the ecosystem because a lot of this requires operating system support, and making sure that the ISVs can take advantage of the entire stack. That's the journey a company like Intel is on right now, to really bring that innovation to market.
What about the industry at large and the field of confidential computing? Where do you feel like it's going, and where would you like to see it go? What stands out as especially important to you?
I don't think it's a technology problem around confidential computing. I think we have enough technology around it. The problem is, if you go talk to your friends about confidential computing, they're probably going to blink at you. The awareness of confidential computing is just starting to get out there, right? Forums like this help, because it's not just an echo chamber where practitioners come and tell each other what they're working on. People who eventually would buy this technology come listen to it. And the more use cases and the more production solutions we can talk about gives confidence to the industry, not just to the confidential computing folks, but for the general purpose industry, that they can actually bring their solution and deliver it in a confidential computing manner. That's what we need to continue doing. We will absolutely innovate on the technology, but I think we need to ooch up the outcomes from the technology and make a big deal about that in the industry, which is what I did my little small attempt today in doing that, so that it's not an esoteric exercise that, somebody worked on a nice little technology, but what's the outcome at the end of the day? That's what the industry needs to focus on moving forward, in my opinion.
Stories of data put to work.
Yep, absolutely. And just talk about it, right? And talk about what problem and what outcome were they able to deliver because of confidential computing. That's what we need to start doing more of. Not saying technology does not need to be innovated. That needs to continue, but let's talk about the solutions and the outcomes we're driving.
We're here at the Confidential Computing Summit, hosted by Opaque Systems. Intel has had a close relationship with the UC Berkeley research that then was productized in the form of Opaque. Can you tell us a little bit about that experience?
Sure. Our partnership with Opaque, and now recently with Aaron, the CEO, is pretty strong, because I think Aaron and Opaque understands the vision of how do you take advantage of hardware capabilities along with software to deliver outcomes as systems, right? Rather than just doing it in software and saying, I don't care about the hardware. I think the company has this vision of delivering systems together, and they've been a great partner, and I hope they continue to be a great partner of Intel in this journey of confidential computing.